Today's lesson is on matrices. Just to clarify, if you have a matrix, that is one, but the plural is called matrices. So just so you know what I'm talking about when I say matrices, that means there's two of them. Matrix is one. A matrix is really just a way of organizing your information. And so if you have a table, it's very similar. If I had this table, I could organize this information into a matrix just by rewriting the same numbers and just taking off the words. So I can just rewrite this and have the same information, but it's in a matrix. Now, the advantage is that we can do a lot of stuff with matrices, and we know how to do some operations with matrices. So there is my matrix that I created just by taking this table and putting it into a matrix form. So that's what a matrix looks like, and that's what a matrix does. We need to talk about some different parts of the matrix. So when you have a matrix, each number inside the matrix is called an entry. The matrix is made up of rows and columns. Rows go across, columns go up and down. And when we talk about matrices and their sizes, because we'll be talking about the sizes of matrices quite a bit, we talk about rows by columns. For example, if I look at example A, this matrix is a 2 by 3 matrix because there are 2 rows and 3 columns. Take a break here and fill in what would be the size of example B and what would be the size of example C. Okay, hopefully you were able to figure out that example B is a 3 by 2 and example C is a 4 by 1. It is rows by columns, rows by columns. How do we add and subtract matrices? Because we're going to be doing all sorts of different operations. When you add and subtract matrices, all you have to do is just add the entries that are in corresponding positions. So let me show you what I mean here. I'm just going to add -5 plus -3, and that's -8. 8 plus -4 is 4. -9 plus 0 is -9. Do you see how I'm just taking each corresponding position and adding those together? The bottom row is going to be 15, 6, and 7. So that's how you add matrices or subtract. Sometimes there is subtraction. So take a minute to look at example 2 and 3 and see what you get for those matrices. Pause it here and see what you get for those matrices. All right, on example 2, this was a subtraction problem, so make sure you had the subtraction. So -2 minus 7 is -9, etc. So check your answer there, see if you got those answers. Example 3 is not possible, and the reason it is not possible is they are not the same size. That there's no way to add these together if they are not the same size. Because this one is a 2 by 3, and this one is a 3 by 2, and so those aren't the same size. If they don't match up, there's no way to add them. Let's go on to the next page. Next page, we're talking about multiplication. And when we multiply, there's a couple different types of multiplication. This is called scalar multiplication. Scalar multiplication is when you just have one number outside and you're multiplying the whole matrix by that number. And to do that, you just distribute the number and you multiply each entry. So if we do this on example 1, 2 times 6 is 12. Excuse me. 2 times -2 is -4. 2 times -3 is -6, that's a 12. And 2 times 8 is 16. That's all you have to do with scalar multiplication. It's pretty easy. So if we look down here, the first one says find 2c. So let's go ahead and do what is 2 times c. Why don't you pause here, fill in what you think is the answer for 2 times c. Okay. When you multiply 2 times c, you should have gotten 0, -8, 6, and 14 in your matrix. Let's try this example. It says find 2c. We did that one. We'll save a plus b for later, and we might do this one later also. Let's just do a plus 2 times c. So if we take a plus 2 times c, then what is that going to give us? Well, we've already figured 2c, so that's easy. So now we just have to add these two together. So if we add these two together, we're going to get a negative 8, positive 7 down here, positive 1 here, and 11 here. So that is what you get when you add a plus 2 times c. You would have to do 2 times c first, which we did, and then we're going to add those together. Sometimes this actually shows up a lot on tests like ACT and things like that, where there are some missing terms. So let's just kind of take a look at what's going on and see if we're able to see what it is. So 2 times 5 would be 10. We have that. The rest of them are kind of blanks. So I'm going to come over here, and one way to do it is say, well, 2 times a is supposed to be 14, and so a must be 7. Do you see how I did that? 2 times a is supposed to be 14. Now, I showed my work. Some of you probably will want to do this without showing work, and that's okay, because this is a pretty basic one we could probably do. Let's look at b. It should be 2 times b is 22, and so we can see that b is 11. And then if we look at c, well, it should be 2 times negative 9 is equal to c. So c must be negative 18. So again, that is being able to look at the different pieces of the matrix is a skill that is tested on ACT. So I want to make sure that we did some that have some variables in it. Well, what if the whole matrix is a variable? Because this says find the missing matrix. In other words, they are implying that there is a matrix here called matrix A. So that's what we need to take a look at. I'm going to try to fit this in here. What really this means is, imagine if this was an equation, which it is, but if this was an equation and you were going to solve this equation, if we were going to solve this, wouldn't we divide by 3 on this side and divide by 3 on this side? And that's going to cancel my 3's, and it's going to tell me what A equals. Well, the same thing here. If we divide this by 3 and divide this by 3, what will we get? Well, to get the answer, we're going to need to divide everything divide by 3. So 27 divide by 3, negative 72 divide by 3, 0 divide by 3, etc. So we're just dividing each term, each entry, divide by 3 to get our answer matrix. So the answer matrix is just this matrix. That's what A equals. So if it says to find the missing matrix, a couple things. You can do the same operation that you would do to solve an equation. It's just that the answer is a full matrix. Okay, similar type thing. And we might even write something out in the margins here. Maybe solve like an equation. Solve like an equation to simplify. So if we solve this like an equation, again, we're trying to find the missing matrix that would satisfy this equation. Just imagine these were numbers for a minute, like just single numbers rather than whole things like this. What are some things you could do? Well, one thing you could do is you could go ahead and distribute this. So let's go ahead and distribute this and call it 10, 2, 12, 4. And then we're subtracting 3a equals this. So again, I'm just going to solve this like I would solve an equation, because the next thing I would do is, wouldn't I subtract this matrix from both sides? Okay, I'm going to subtract that matrix from over here. All right. So now I'm going to come over here. I've got negative 3a is equal to, okay, I need to subtract these matrices. So that minus should be outside, not right there. Okay, so 3 minus 10 is negative 7. 12 minus 12 is 0. 20 minus 2 is 18. And 16 minus 4 is 12. So I'm just solving it like pretending like it was an equation, and you just work it out. I'm not done yet because I still need to finish out the equation. And so I need to divide by -3, right? So I need to divide this by -3. I'm running out of space, but my answer is going to be -7 divided by -3 is a fraction. 18 divided by -3 is -6. 0 divided by -3 is 0. And 12 divided by -3 is -4. So the answer matrix is what you could plug in for A to find this answer. Now, we had to do some solving, but just solve it like a regular equation and then simplify it to get your answer matrix. These all come from coolmath.com. You guys have probably played math games on coolmath.com, but they go all the way up to pre-calculus on coolmath.com. So this is a link where if you want to see more of this information, they will have that there in coolmath.com. And I'm looking at it and it says matrices. I'm not sure if this is going to be it, but definitely you could go to coolmath.com and find some of this information. Okay, summary. What are some things that we need to write down? Well, one thing is when you solve a matrix equation, we really use the same steps as we solve a regular equation. So we use the same steps to solve like we would solve a regular equation. Something we talked about with adding, to add or subtract, just add the entries in the corresponding positions. And then for multiplication, scalar multiplication, for scalar multiplication, distribute. That is all we are doing today. These problems should be pretty easy because it's really just basic arithmetic. It's just having a whole matrix with it.